Linear blend skinning for skeletal deformation is simple and fast. However, it does not properly handle stretching, where bones change length, or twisting, where the shape rotates along the length of the bone. Twisting is packed near joints and suffers from the candy wrapper effect. Stretching causes shape explosion. Dual quaternion skinning eliminates joint collapse and candy wrapper artifacts. But twisting is still isolated near joints, and stretching still causes shape explosion. We present stretchable, twistable bones. We derive a simple modification of the linear blend skinning and dual quaternion skinning formulations. Our formulation only requires an additional set of weights for each bone, which we call endpoint weights, as they reveal correspondences between the shape and the endpoints of each bone. Deformation computation remains embarrassingly parallel, and the extra storage and computation costs are minimal. Previous improvements to linear blend skinning focus on joint collapse and candy wrapper artifacts. We show that proper stretching and twisting lie outside the space of possible deformations with these methods because they depend solely on bone weights. With only one bone controlling this cigar shape, the weights of linear blend skinning and those of its improvements must be one everywhere. Thus, stretching or squeezing the bone results in scaling the entire shape, exploding the regions beyond the bone's endpoints. The bone weights in our method must also be one everywhere, but our endpoint weights may vary, so proper stretching and squeezing is achievable. By the same logic, in 3D, linear blend skinning and its improvements cannot propagate twisting along the length of a bone. Previous methods must pack twisting near joints where bone weights briefly overlap. Our method allows twisting along a single bone, along a bone and the joint, or along both bones. Bone weights have been successful because they capture the natural rigidity of body parts. They perform well at bending. However, they are poor at controlling behavior along bone lengths, as is needed for stretching. Recent work has shown that point handles and point weights are a powerful alternative. Point weights properly treat stretching by blending translations, but struggle to maintain rigid regions when bending. We combine point weights and bone weights, allocating each to the tasks they are good at. Our method bends at joints and stretches without shape explosions. Previous methods with extra weights rely on input example poses, which often do not exist. Our endpoint weights have a clear geometric meaning. As a result, they may be painted manually or computed using recent automatic methods. Our method does not require changes to existing skeletons or bone weights, and our method complements the typical skinning pipeline without changing the rigid skeleton metaphor or interfering with existing controls. Stretchable bones facilitate exaggerated actions. Animators regard exaggeration as a basic principle to produce the illusion of life. Stretchable, twistable bones give animators more artistic freedom. Endpoint weights may be filtered interactively using spline filters common in animation environments. With our method, bone joints may be dragged about freely without worry that changes in bone length will cause explosion artifacts. Thank you for watching.